Hi, everybody. So I'm Yannick Van Doorne, and I will present you a series of articles about electroculture. So let's begin with the first article. So in English, we have this one. This is an article you find in the Encyclopedia of Organic Gardening of 1978. So it's quite old. But I like the old articles. And so let's see what's inside. So it's an encyclopedia from the USA, I think, from the United States, or from Canada. It's one of the two. So we will see here. So new revised edition, Organic Gardening Magazine, Rodale Press, Pennsylvania. So it's a United States, I think. And so we will look. It's very rare to see articles about electroculture in that period, because after World War II, almost everything about electroculture was censored. It was ignored or forgotten. But sometimes we find things. So here, this is the article. Electroculture. Electroculture is a method of setting up an electrical field to influence the growth of plants. The word electrical in this sense does not mean a conventional electric current, but atmospheric, magnetic, and terrestrial electricity. According to research, this electricity has been found to have some beneficial properties for plant growth and germination. The basic principle is that wherever there is a cellular activity, there is electrical energy developed. And conversely, wherever electrical energy is applied, cellular activity is increased and better growth obtained. Electroculture is the science of securing this growth through the application of electricity by using suitable techniques. Probably the first electroculture investigator was a Frenchman, Mr. Berthelon, whose electrovegetometer supposedly collected atmospheric electricity by means of an antenna and passed it through plants growing in the field. He found an acceleration of growth in treated plants as compared to untreated, and reported these results in his treatise entitled On the Electricity of Vegetables, published in 1783. So I can show you this book. I have it, but it's only in French for the moment. But maybe I will do the work to translate it in English. It could be very interesting to do that. So we continue. About 50 years later, in 1844, W. Ross, an American, applied for a patent for a device or system using large zinc and copper plates, which he buried in the ground about 200 feet apart. The plates were connected above ground by wire, thus forming a galvanic cell, and potatoes were planted in the rows between the plates. It was believed that larger than ordinary potatoes were obtained this way, but total yields were not given, and Ross reportedly did not specify that soil of a uniform quality and texture was used. So in reality, a similar system was also developed or discovered by a Russian guy, Speshnev, and he had, in most cases, double yields or even more in a lot of cases. But I would say average more than 30% more yield just by burying a copper and a zinc plate at a distance and connect it with a wire and with the plants in between. Speshnev did it even on fields like of 1 hectare or 2 acres and a half big, so with huge results. So it's a very easy way to do electroculture, very interesting way, and still works. So it's very interesting. So we continue. So like you see, I give sometimes my comments through my experience from more than 20 years that I'm passionate about electroculture. I've read a lot of things about electroculture, and I've done also a lot of experiments since 20 years in my own garden and with farmers since 20 years. So um, I just want to share you all that experience so you can learn even more rapidly and continue that work. So it's just to help you and to continue to develop electroculture. I have my own ideas naturally, and so sometimes I can be wrong, and sometimes I said things a few years ago that I'm not agree anymore today because I evolved too. So it's a very interesting subject in the way that we have all to discover again, and that it's very interesting, and let's make it happen. Let's talk about this. Let's exchange about this, and most important, uh, let's do experiments in our garden and exchange the results and observations, because it's through the real experiments that we see real results and that we can see real observations that can help us to understand better how it works. So let's continue. From about 1900 to 1920, numerous experiments with atmospheric electricity were conducted by horticultural researchers. Usually, wire nets were used, suspended at varying distances above the experimental field and held there by insulated supports. One terminal of the voltage source was attached to the net and the other was grounded. So that's a kind of system you find back in the book of Lemström. It's a guy from the Northern Europe. And he did 1 century ago, even more than 1 century ago, experiments with that kind of systems. With also huge research, but that kind of systems with a wire net above the plants, it's a lot more heavy and complicated and expensive to install and to use. So it's not very practical system. The system just before is a lot more practical, a lot more easy, and a lot more cheaper with also huge results. So let's continue. Research continued through the first half of the 20th century and into the 1960s. Tests were carried out at the Massachusetts Experiment Station as recently as 1962. E.G. McKibben, director of the Agricultural Engineering Research Division of the USDA, presented a paper before the American Society of Agricultural Engineers entitled "A Look Ahead at the Farm Electrification Research." In this paper, McKibben spoke highly of the many possibilities of the application of electromagnetic energy in its many forms to agriculture. And up until 1967, Rodale Press was conducting successful electroculture experiments at its experimental organic farm and reporting on them in Organic Garden. That in the magazine of Organic Gardening and Farming that electroculture results since 1967, and it's an article of 1978. So they had already shared 11 years of their experience. So let's find that back, maybe. Very interesting. So let's continue. Electroculture technique. The following methods have been used by experimenters in electroculture, in which the seed is sown in a bed provided with half-an-inch iron wire netting. For a plant or tree, a jacket of apron is formed 1 inch to 1 foot wide, depending on the grid, and placed around the stem or trunk. For individual branches of a tree, a collar of the same wire netting is formed. So, interesting way of doing to receive and transmit radiomagnetic energy. So interesting. Number 2, treatment of seed before sowing, either by spreading it out in a thin layer on an insulated metal plate and then giving the plate a high tension spark of 2000 volts for 1 minute, or by soaking the seed in electrified water in an insulated vessel for 1 or 2 hours. In both methods, the seed is sown without being touched. So, treatment of seed before sowing, there are a lot of different techniques. Some works well, some not, some are practical, some are not practical. So here they show or explain only 2 ways, but it can give you ideas to experiment, and I really advise to do that, because it's a really simple way to improve a lot the growth and the yields. But be careful, because if you don't use the right tension, duration, right electricity, you can have also bad results. So be careful with your experiments. You can really increase the growth and germination, but you can also do the opposite if you with certain electricity. So just experiment to find the right way to have good results. And there is not only one way, and there are many ways to do it. Okay, number 3, giving the plant electrified water. Whenever a growing part is given such a mantle of electrified water, its growth is increased. This is much more than irrigation, which is watering the roots. Water is electrified by taking it in an earthenware container, placing it on a rubber mat, dipping one end of a high-tension cable in the water while the other is hooked onto the ignition plug of a car, and the engine runs for a minute. So, yes, that's a way of doing it. They use that kind of way now. Also, they call it plasma-activated water, for example, where they do high-tension discharge on the water. It's very, very powerful. It works very well. You can also magnetize your water with just magnets. It also improves the growth of the plants with magnetized water. So you have, again, many ways of doing it, but the way they explain is very easy way and very effective way to do it. So number 4, interculture of the growing plant with other suitable plants, such as are rich in M rays or Gurwitch rays or ultraviolet rays, like onions and other root crops. Other radiations are also effective, such as X-rays, ultraviolet rays, violet rays, etc. But the exposure should not, as a rule, exceed 1 minute. So here they bring an idea that is very interesting too, is that each plant radiates also certain waves that can be beneficial for another plant. And you have plants like onions, like root crops, but onions that are have a very high vitality, vital force or life force that they radiate all around, and this can be very beneficial. So it's about companion planting, for example. It's very interesting to look not only about the chemical and physical effects of certain substances of the plant that gives advantages to other plants, but also about their radiation. And also the color. I would add to that the color can also help a lot. An example, if you have certain flowers, so I will just if you have, for example, certain flowers in yellow, well, this will attract certain insects, but will repel other insects. So every color has an influence on the environment. And so if, for example, you have a crop that is attacked by certain insects, you could put a flower close by with the color that repel that insect to protect the crop. So you have a lot of new ideas that can germinate like this, and it can work very well. And now, if you see it like this, you will see nature completely differently. You see, just by that little article and but by those ideas, you see now that electricity, radiation, colors is also an electromagnetic radiation, that all those influences have a huge impact on plant growth and soil fertility. So, and it's all around us, so we can begin to observe things. When we will see a flower and their insects, we will not see just a flower and insects. We will see a flower, a color, we will see insects that are attracted to certain colors, or and so on. And maybe we will begin to observe that certain insects are never on that plant, but they are on this plant. So you see, it's like this that we have also discovered in the electroculture, in my electroculture community, that certain plants are very useful against slugs because by accident we saw that that certain plants really repelled certain slugs. So then we can put some leaves of those plants around the crops that we want to protect, like around our salads, lettuce, and cabbages that normally the slugs like to eat. Well, we can put some leaves of another plant that repelled it, and so they are protected. And it works very well. So we will talk about this later on too. So thank you. So let's continue. So the article is quite yes, at the end. So then it's like a dictionary. So the other next word is elm. It's about a tree. So this was in the Encyclopedia of Organic Gardening of 1978. So like you see, of Rodale Press. So edited by Rodale Press. Very interesting, very nice. So I hope it was also interesting for you. That's the aim. It's to share you interesting information that I have gathered or assembled over the years to help you to to discover more about electroculture. Yeah, so so thank you very much, and bye bye till next time. Bye bye. So I will put again my teaser, little teaser, just an experiment, but I will make a new one, I think, or improved one. But here.